Hello everyone, I am Manaswini Kishore, currently an intern at Emertxe Information Technology. We are a group of five, I and Chandini, Jyotika, Jayalakshmi and Uday Satyakiran. We are doing this internship based on embedded systems, and during this internship we have developed a project based on MPLAB IDE and simulated on PICSIMLab. We have worked on a project that is a microwave oven simulator. So let's go on to the contents. Introduction part, block diagram, working, software materials used, embedded program, applications, advantages and disadvantages, and at last, conclusion. So, introduction part. A microwave oven is a kitchen appliance, an electronic oven that heats and cooks food by exposing of electromagnetic radiation in the microwave frequency range. It is a embedded system interface with external environment by means of several sensors and actuators. So we'll learn what is a embedded system. Hardware plus software is a embedded system. So here we have the block diagram of microwave oven. So here you can see the power circuit, temperature sensor, humidity sensor, etc., LCD panel, magnetron, IGBT, and the temperature sensor, humidity sensor, etc., is connected to the A to D and PWM, LCDC, serial, IF, GPIO. So these are connected to PORIC, recommended non-volatile memory. So this is the internal structure of this microwave oven. And let's get into the working. A magnetron takes electricity from the power outlet and converts it into high power during cooking. The magnetron blasts these waves into the food compartment through the channel. So here you can see how it works. And so get on to the software materials used. Here we have used MPLAB X IDE v5.50 version and the PICSIMLab PICGenios PIC16F877A version. And so let's get on to the part of architecture of PICSIMLab. So this is the architecture of the PICSIMLab. So we have the ports like GPIO, I2C, RTC, EEPROM, and LM35 temperature sensors, and more ports like RS232, LEDs, buzzer, digital keypad, SSDs, matrix keypad, and etc. So here we can see the Vixim lab, and let's get into the embedded programming. Here you can see, and further we can run these codes. Okay, and let's get on to the applications. Detecting and non-metallic weapons, postal screening of envelopes for bacteria, homeland security applications, potential security applications, and detection of hidden weapons and explosives, biochemistry, biodetection, security screenings, and etc. So now we are going to discuss the advantages and disadvantages. So the advantages are volumetric heating process, quick and convenient method of heating food, and user interface and precise control over the cooking temperature. So and and so on. And the disadvantages are cost of equipment is very high. Unsafe microwave dish will set off a chemical reaction between the food and the container. Exposure to high levels of microwaves can cause a painful burn by heating of body tissue, cancer. And the last part is conclusion. Microwave processing technology require learn learn and understand. Microwave oven will update according to technology and most likely candidates for future production. Scale applications will take full advantage of the unique characteristics.
So far we have executed as shown as you can see the code, and we are using MPLAB X IDE 6.15 is my version of MPLAB X IDE, and I have created a microwave oven project which has the header files as clcd.h, main, and matrix keypad, which also consists of a header file and a timers. And the timers that we are using in this is 4x4 matrix keypad, and it has the following source files also. So as you can see the code, and it has all the modes that are required for the microwave oven. I'm going to build it. Yes, the output is successful, so we can stimulate in the PICSIMLab. Okay, so I'm going to use the board of this PICSIMLab. I'm going to use it as PICGenios, so which has yes, as you can see, it is a PIC16F877A is the version of the microcontroller that we are using for this project. So I'm going to load this hex file that we have coded in the MPLAB X IDE from this documents, as you can see. So we have to use the hex file for the code running. So you can see the powering on of the microwave oven in the before slide, right? So and once the oven is started, we have the four following modes, which is micro mode, grill mode, convention, and the start or resume mode. So micro mode, we have seen earlier why we have to use micro mode, grill mode, and convention mode and start mode. So we are going to see the execution part in this output here. See, I'm going to press the key 1 for the micro mode, and it has a power of 900 watts. So I'm going to set the timer as per my cooking requirements. Say 45 seconds and 2 minutes. Okay, let's enter. As you can see, the timer is started and the fan is running. Okay. If you want to stop it, or else if you want to go for the other mode, you can just stop it and go for the menu bar. Or else if you want to resume it, and again you have to press the micro mode and set the time. It's up to you, whatever the time you want to set. It's upon the timer. Okay. If you want to stop it or pause it, press switch number 5. Such that you can see the fan is stopped and the heater is stopped, right? Okay, if you want to give an indication to the user, you can just simply press RB3. See, if you want to continue it, press 4, and you can, yeah, this is how the user is informed through a buzzer. Okay, now let's go for the previous session. For that, you just have to stop this. Okay, what if I wanted to go for the grill mode? I just simply have to select the option number 2 and then set the timer. See, let's 12 seconds and 1 minute. Yeah. Okay, see, the timer is going to be reduced initially, and then the fan and the cooler starts cooking. Okay, now let's go for the other mode. I'm going to stop it, and then I'm going for the convention mode. Yeah, what is convention mode? Where the heater is preheated such that the cook can be, it is preheated. So I'm going to set an initial time temperature, say 45 degrees Celsius, and then I'm going to enter it. So you can see, right, preheating time temperature. So this is how you get the output of a convention mode. And similarly, if you want to tell the user or else the owner of the you can do it with a beep. Okay, so this is the output of the project, and now let's go for the okay. So this is how we have seen the power on screen, and it has the following 4 modes: micro mode, grill mode, convention, and the start mode. So which is followed by 900 watts power. Grill mode, we have to set the temperature, and then we have to go for the other mode. In case of convention mode, as the oven is being preheated, it is going to ask you the temperature, and it depends on the requirement, and then you go for the preheating. Once the preheating is done, you will be notified with a buzzer. We're going to send an alarm for the user. That's it. Now once it is done, the door status can be notified to the user. Okay, thank you. And at the end of the session, I wanted to say thank you for the Emertxe for letting us to know such a valuable information, and a word of thanks would be very much less for them. And thank you for this opportunity, and the outcomes from the project are very useful for us. And also the last few sessions from the workshops also made us understand what's the current situation for an electronic students in the outside world. And thank you very much for this opportunity. Thank you.